All right, so we're going to look at this example now. This is another example of a separable equation. Note that this and this are two different functions. 6x squared is a function of x alone, and 1 over 2y plus cos y is a function of y alone. So this indeed is a separable equation, and we can do our cross multiply and integrate trick to solve it. So that's what we get if we cross multiply, assuming that these infinitesimals can be separated, or assuming that we can multiply the infinitesimals out like a fraction. We can sort of legitimize that step by integrating. So this is what we've got to do now. We've got to actually do this integral. Both of these integrals are fairly tractable. This one's a polynomial. That's going, a cos goes to a sine, and that's another polynomial. So we've got 2y squared on 2. Integral of cos is sine. I'm going to ignore the constant on the left-hand side. I'm just going to put one constant on the right-hand side. Add 1 to the power, divide by the new power, and there's my constant. Note that if I've got a constant on the left-hand side, I can always move it to the right-hand side, so I only need to put in one constant. Okay, and I'm done. Typically we want y by itself. This expression it's not tractable to simplify that for y equals something. So we've just got to live with this parametric form of the solution. Obviously, we can solve this. We can plot the solution of this. We can take particular examples of x and y, and we can actually draw what the solution looks like for particular values of c. So this is still C is still unknown, but we know that it's related to any initial condition that we might be prescribed. I'm just going to sketch a few solutions to this. You won't be expected to sketch these solutions. This is actually this is done using a computer algebra package. So I'm just copying the picture. There's sort of one that comes down, kind of hugs the axis a bit. And so you sort of expect a caustic or a cuspy type solution somewhere in here as well. All right, so that's kind of what the solutions to this problem look like. Obviously, you can just plot this in a parametric sense.